A disconnect is required between the meter can and the breaker panel when the distance between these two components exceeds 6 feet. This requirement is primarily driven by safety considerations and the need for readily accessible means of disconnecting electrical power in emergency situations. The purpose of having a disconnect located within a reasonable distance of the meter is to allow emergency responders, electrical workers, or homeowners to quickly and safely energize the electrical system. This can be crucial in situations such as electrical fires, flooding, or other hazardous events. The 6-foot rule is not an arbitrary number. It is based on the understanding that, in an emergency, someone should be able to locate and operate the disconnect swiftly. If the distance were significantly greater, valuable time could be lost, potentially exacerbating the emergency. Now let's delve deeper into the underlying principles and related factors that influence this requirement. Firstly, the National Electrical Code, or NEC, plays a significant role in defining electrical safety standards in the United States. While the NEC does not explicitly state a 6-foot rule in all jurisdictions, it provides a foundation for local electrical codes that often adopt this specific requirement or similar standards. Local codes are developed and enforced by local authorities, such as city or county governments, and these codes can vary depending on the specific needs and conditions of the region. Therefore, it is essential to consult the local electrical code in the area where the electrical installation is being performed to ensure compliance with all applicable regulations. Secondly, a term readily accessible is a key concept in electrical codes. This means that the disconnect must be located in a place where it can be reached quickly and without obstruction. The disconnect should not be hidden behind obstacles, locked in a room without easy access, or placed in any location that would impede its use in an emergency. The intent is to ensure that anyone who needs to operate the disconnect can do so without delay. This requirement is essential for safeguarding lives and property. Thirdly, the type of disconnect used is also important. Disconnects come in various forms, including circuit breakers, fuse disconnects, and knife switches. The specific type of disconnect required may be specified by the local electrical code or the design requirements of the electrical system. The disconnect must be properly rated for the voltage and current it is expected to handle. An undersized or improperly rated disconnect could fail to operate correctly in an emergency, potentially leading to dangerous conditions. Fourthly, the installation of the disconnect must be performed by a qualified electrician. Electrical work can be hazardous, and it is essential to have the work done by someone who is trained and experienced in electrical installations. A qualified electrician will be familiar with the local electrical code and will be able to ensure that the disconnect is installed correctly and safely. This includes proper wiring, grounding, and bonding, as well as ensuring that the disconnect is properly labeled and accessible. Fifthly, regular inspections of the electrical system, including the disconnect, are crucial for maintaining safety and preventing problems. Over time, electrical components can deteriorate due to environmental factors, wear and tear, or other causes. Regular inspections can identify potential problems early on, allowing for timely repairs or replacements. Inspections should be performed by a qualified electrician and should include a thorough examination of the disconnect, wiring, and other related components. Sixthly, let's consider the scenario where the distance between the meter can and the breaker panel exceeds 6 feet. In such cases, an additional disconnect is required to be installed closer to the meter. This disconnect serves as the primary means of disconnecting power in an emergency. The breaker panel itself may also have a main disconnect, but this is typically located inside the building and may not be as readily accessible as a disconnect located near the meter. Seventhly, the location of the disconnect should be clearly marked. This can be done using labels, signs, or other means of identification. The marking should be durable and easy to read even in low light conditions. The purpose of the marking is to ensure that anyone who needs to operate the disconnect can quickly locate it, especially in an emergency. Eighthly, it is important to understand the difference between a service disconnect and a branch circuit disconnect. A service disconnect is the main disconnect that controls the entire electrical service to a building or structure. A branch circuit disconnect, on the other hand, controls only a portion of the electrical system, such as a single circuit or appliance. The disconnect required between the meter can and the breaker panel is typically a service disconnect, as it controls the entire electrical service. Ninthly, let's discuss the grounding and bonding requirements for the disconnect. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to trip and energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, reducing the risk of electric shock. The disconnect must be properly grounded and bonded in accordance with the NEC and local electrical codes. Tenthly, the size and type of conductors used to connect the meter can to the disconnect and the disconnect to the breaker panel must be properly sized for the load they are expected to carry. Undersized conductors can overheat and cause a fire hazard. The conductor size is determined by the ampacity of the circuit, which is the maximum amount of current the circuit is designed to carry. The NEC provides tables that specify the allowable ampacity of different types of conductors based on their size and insulation type. 11thly, the overcurrent protection devices, such as circuit breakers or fuses, must be properly sized to protect the conductors and equipment they serve. Overcurrent protection devices are designed to trip and energize a circuit when the current exceeds a certain level. This protects against overloads, short circuits, and other electrical faults. The size of the overcurrent protection device is determined by the ampacity of the conductors and the rating of the equipment they are protecting. 12thly, the disconnect must be installed in a weatherproof enclosure if it is located outdoors or in a damp or wet location. A weatherproof enclosure protects the disconnect from the elements, preventing corrosion and other damage. The enclosure must be properly rated for the environment in which it is installed. 13thly, the disconnect should be readily accessible for maintenance and repair. Over time, electrical components may need to be replaced or repaired. The disconnect should be located in a place where it can be easily accessed by a qualified electrician. 14thly, it is important to keep the area around the disconnect clear of obstructions. This ensures that the disconnect can be easily accessed in an emergency. Do not store boxes, equipment, or other items in front of the disconnect. 15thly, consider the voltage drop in the conductors between the meter can and the breaker panel. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop depends on the length of the conductors, the size of the conductors, and the amount of current flowing through them. The NEC recommends the voltage drop be limited to a certain percentage of the source voltage. 16thly, when installing a disconnect, it is important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install and operate the disconnect correctly. Failure to follow the manufacturer's instructions can result in improper operation or even failure of the disconnect. 17thly, ensure that all electrical connections are tight and secure. Loose connections can cause arcing, which can lead to overheating and fire. All connections should be made using the proper tools and techniques. 18thly, the disconnect must be properly labeled with its function. This helps to ensure that people know what the disconnect controls. The label should be durable and easy to read. 19thly, it is important to keep a record of all electrical work that is performed. This includes the date of the work, the name of the electrician who performed the work, and a description of the work that was performed. This record can be helpful for future maintenance and repairs. 20thly, when replacing a disconnect, it is important to choose a replacement that is the same size and type as the original. This ensures that the replacement disconnect will properly protect the electrical system. 21stly, be aware of the potential hazards of working with electricity. Electricity can be dangerous, and it is important to take precautions to protect yourself from electric shock. Always turn off the power before working on electrical equipment and use insulated tools. 22ndly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the training and experience to safely and properly perform electrical work. 23rd, the location of the meter can and the breaker panel should be chosen carefully. The meter can should be located in a place where it is easily accessible for meter reading and maintenance. The breaker panel should be located in a place where it is protected from the elements and easily accessible for maintenance and repairs. 24th, consider the aesthetics of the electrical installation. While safety is the primary concern, it is also important to consider the appearance of the installation. The meter can and breaker panel should be installed in a way that is neat and professional looking. 25th, when running conductors between the meter can and the breaker panel, it is important to protect them from damage. Conductors can be damaged by physical impact, abrasion, or exposure to the elements. Conductors should be run in conduit or other protective raceway. 26th, be sure to comply with all applicable building codes and regulations. Building codes and regulations are designed to ensure the safety of buildings and their occupants. Electrical work must be performed in accordance with these codes and regulations. 27th, it is important to keep the electrical system clean and free of debris. Dust, dirt, and other debris can accumulate on electrical components and cause them to overheat or malfunction. The electrical system should be cleaned regularly. 28th, when working on electrical equipment, it is important to wear appropriate personal protective equipment. This includes safety glasses, gloves, and other protective gear. Personal protective equipment helps to protect you from electric shock and other hazards. 29th, be aware of the signs of electrical problems. These signs can include flickering lights, sparking outlets, and burning smells. If you notice any of these signs, it is important to have the electrical system inspected by a qualified electrician. 30th, it is important to have a plan in place for dealing with electrical emergencies. This plan should include the location of the main disconnect, the phone number of the local fire department, and the phone number of a qualified electrician. 31st, understand the concept of short circuit current rating, or SCCR. All electrical equipment has an SCCR, which indicates the maximum short circuit current the equipment can safely withstand. The available short circuit current at the equipment's location must be less than or equal to the equipment's SCCR. This is a critical safety consideration to prevent equipment failure and potential hazards during a short circuit event. The disconnect switch must have an appropriate SCCR for the application. 32nd, consider the ambient temperature where the disconnect is installed. High ambient temperatures can affect the ampacity of conductors and the performance of electrical equipment. The NEC provides correction factors for ampacity based on ambient temperature. The disconnect switch must be rated for the ambient temperature in its location. 33rd, regularly inspect the disconnect for signs of corrosion. Corrosion can damage electrical components and lead to equipment failure. If corrosion is found, the affected component should be cleaned or replaced. 34th, when installing a disconnect, ensure that it is properly aligned and supported. Misalignment can cause stress on the conductors and connections, leading to premature failure. The disconnect should be supported in accordance with the manufacturer's instructions and applicable codes. 35th, consider the use of surge protection devices, or SPDs. SPD protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. SPD can be installed at the service entrance or at individual pieces of equipment. 36th, understand the different types of enclosures that are available for disconnects. Enclosures are rated according to their ability to protect the equipment from the environment. Common enclosure types include NEMA 1, NEMA 3R, NEMA 4, and NEMA 4X. The appropriate enclosure type depends on the location of the disconnect and the environmental conditions. 37th, be aware of the requirements for arc flash protection. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or other electrical fault. Arc flash can cause severe burns and other injuries. The NEC requires that employers provide arc flash protection for their employees. This protection can include personal protective equipment, or PPE, and engineering controls. 38th, consider the use of ground fault circuit interrupters, or GFCIs. GFCIs protect people from electric shock by detecting ground faults and interrupting the circuit. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. 39thly, ensure that the disconnect is properly sized for the load it is serving. An undersized disconnect can overheat and fail, while an oversized disconnect can provide inadequate protection. The disconnect should be sized in accordance with the NEC and local electrical codes. 40thly, when replacing a disconnect, be sure to properly dispose of the old disconnect. The electrical equipment can contain hazardous materials such as lead and mercury. The old disconnect should be disposed of in accordance with local regulations. 41stly, understand the concept of impedance. Impedance is the opposition to the flow of alternating current, or AC. Impedance is made up of resistance and reactance. High impedance can limit the amount of fault current that flows during a short circuit, which can reduce the severity of an arc flash. 42ndly, consider the use of fuses. Fuses are overcurrent protection devices that melt and interrupt the circuit when the current exceeds a certain level. Fuses are available in a variety of sizes and types. The appropriate fuse type depends on the application. 43rdly, regularly test the operation of the disconnect. This can be done by manually operating the disconnect and verifying that it properly interrupts the circuit. Testing the disconnect helps to ensure that it will function properly in an emergency. 44thly, consider the use of a transfer switch. A transfer switch allows you to switch between two different power sources, such as the utility grid and a generator. Transfer switches are often used in emergency power systems. 45thly, understand the requirements for labeling electrical panels. Electrical panels must be labeled to identify the circuits that they serve. The label should be clear and easy to read. 46thly, consider the use of a power quality meter. A power quality meter can be used to monitor the voltage, current, and other electrical parameters of a circuit. This information can be used to identify and diagnose power quality problems. 47thly, ensure that all electrical work is performed in accordance with the latest edition of the NEC. The NEC is updated every 3 years. It is important to stay up to date on the latest changes to the code. 48thly, consider the use of a grounding electrode system. A grounding electrode system provides a path for fault current to flow back to the source, helping to protect people from electric shock. The grounding electrode system must be installed in accordance with the NEC. 49thly, understand the requirements for bonding metal water pipes. Metal water pipes must be bonded to the electrical system to prevent them from becoming energized. The bonding must be performed in accordance with the NEC. 50thly, consider the use of a whole house surge protector. A whole house surge protector protects all of the electrical equipment in your home from voltage surges. Whole house surge protectors are typically installed at the service entrance. The 6-foot distance requirement, while seemingly simple, is interwoven with a complex network of electrical codes, safety standards, and best practices. Adhering to this rule and understanding its implications is crucial for ensuring the safety and reliability of electrical systems. Always consult with a qualified electrician to ensure compliance with local codes and proper installation techniques.